All right, these are your 10 to be simplifying radical expression notes. I'm going to try to keep them short for you after that long 20-minute one, but we don't have a lot of terms to go over today. So just as a little reminder, to simplify a radical, you have to hit all three of these checkpoints. So in order for a radical to be considered simplified, there can't be any perfects under the radicand. You can't have any fractions under the radicand. And you cannot have any radicals in the denominator. So those second two checkpoints we're going to talk about later on. We're still only concentrating on the very first checklist item. And just as another reminder, that the product property basically says that if you have a product, you can break it apart. But we're going to focus in on the reverse of that. So whenever you have that statement, the reverse is also true. And so what that means is if you have two radicals that are being multiplied, you can actually write them as a single radical. And so making two radicals turn into one radical is in fact simplifying. So I know it's not in our checklist, but that's part of simplifying. That's just a basic simplification that if I ask you to simplify and it means to multiply, and I give you 3 times 5, you better rewrite it as 15. That's a simplified form. So that's what we're going to do today. Now, after we put it back together, we may need to take it apart differently to pull a perfect out. So let's just do rather than me sit here and talk about it. So looking at number 1, we have the square root of 12, which is ugly, times the square root of 3, which is also ugly or irrational. Now, my eyes are trained. I can see that there's a perfect living inside 12. I know that 4 is living inside there, but I'm going to wait, and I'm just going to hold on to that. I'm going to put together first and then take apart if I need to. And so when I put these together, a 12 times a 3 is 36. So rather than looking at 2 radicals, I can look at 1 perfect radical in this case. So 2 irrational radicals actually end up being a perfect square. So 12 times 3 is 36. The square root of 36 is actually 6. So we're simplified completely. Number 2, 5 times 10 is 50. So this becomes the square root of 50. And then I look through my list of perfects, and I realize that 25 is inside 50. So I have to take that out. So I'm going to rewrite that as my perfect square root of 25 times the square root of 2. The square root of 25 becomes a perfect 5 on the outside, and the square root of 2 remains inside. And so that's the simplified form of that radical. It's 1 radical. We put it together, and then we took it apart differently. And so 5 root 2 is a simplified answer of that radical. Number 3, I'm going to multiply the numbers together and then multiply the variables together. So in number 3, I get the square root of 48, x squared. 6 times 8 is 48. X times x is x squared. 48 is not perfect. However, it has a perfect living inside it. And the perfect living inside it is 16. So I'm going to rewrite this as the square root of 16 times the square root of 3, because 16 times 3 is 48. And then I'm also going to rewrite x squared, just the square root of itself. So remember from yesterday's homework, we leave a space. The more complicated they get, I'm going to start using the space out in front and then the radical. That allows me to work right down the line. Square root of 16 becomes 4 outside. Square root of 3 stays inside. And the square root of x squared becomes an x on the outside. So my answer is 4 times x times the square root of 3. I just cleaned it up. And the last problem here, put it together. If I have 3 x's in the first one and another x, that's a total of 4 x's being multiplied together. You add the exponents. For x to the 4th, y cubed. And so I can break that apart. X to the 4th is perfect. Y to the 3rd power is not, but if I break it into y squared times y, we should be okay. So I've got my space for all the perfect out in front, and then my radical. The square root of x squared, you're asking what do you multiply by itself to give you x to the 4th? It's x squared. What do you multiply by itself to give you y squared? Y. and a square root of y stays inside. So I get x squared y, square root of y. I know it's complicated, but that truly is the simplified form of that radical. A few more problems here, a little bit more involved. Okay, so in number 5, I have a number on the outside. Well, technically, I have a number on the outside of the first radical too. It's just a 1. So just like variables, you multiply the outside numbers and then the variables together. We just multiply outside with outside and inside with inside. So 1 times 2 is 2. And then to condense this, I'm going to do the 4 times the 9 is 36. And the a times the b is ab. Well, I recognize that 36 is a perfect. So if you want, if you can figure this out from here, you go right ahead. I'm going to show a little bit more work. Okay, so I have it separated into the perfect and the non-perfect. 36 is perfect. AB cannot be broken down any further. And so when I break up 36, it becomes a 6. But that was being multiplied by 2. I like to circle it so I don't forget about it. 2 times 6 is 12 times the square root of AB. And that's as simplified as you can get. And number 6, last one, now I've got numbers, different numbers on the outside. So 4 times 3 is 12. 10 times 6 is 60. So I have 12 times the square root of 60. When I look at 60, I know 4 is in 60. That's going to take some time. You got to just work with your calculator, practice your multiplication tables. You only are concerned with the numbers in that list, like 4, 9, 16, 25. We don't have to try every number that goes into 60. So I'm going to rewrite this as 12 times the square root of 4 times the square root of 15. The square root of 4 becomes a 2. 2 and 12 make 24 times the square root of 15. 24 times the square root of 15. All right, a little freebie for the lesson summary. And then I just want you to do that last problem there. Good luck. Told you to keep them nice, short, and sweet.